All right, we previously learned how to solve a system of equations with graphing and finding the point of intersection. Then we learned substitution, which is where you solve for one letter first, plug it in and solve for the other. And now we're going to learn elimination, which is kind of similar to substitution, but it's a little bit easier. So we have our two equations, and I am writing them one on top of the other. We are going to add them together. When we add negative 4x plus x, that's 0, which is nothing. So we don't have those x's anymore. Negative 2y plus 8y is 6y. Negative 12 plus negative 24. So that's like we lost $12 and then we lost 24 more dollars. Altogether, we lost $36. Now it's really easy to solve for y. 6 times some number is negative 36. So we can either guess or we could divide both sides by that 6. So we have 1y is equal to negative 6. So now we know what y is. So if we're having our coordinates, that second number is negative 6. So now we just take this and we get to plug it in to either equation. I'm going to plug it in to this one. Negative 4x minus 2 times y, which is negative 6, equals negative 12. So we have negative 4x, negative times a negative is a positive, so positive 12 equals negative 12. All right, so then we have to solve for x. So I'm going to minus 12 on both sides. This is 0 or nothing. So that leaves us with negative 4x here. And over on the right, we lost $12. We lost 12 more dollars. So altogether, we lost $24. Then divide both sides by negative 4. So x is equal to positive 6. All right, and just as a reminder for this y equals negative 6 here, I could plug that into either equation. I just was thinking that a negative times a negative here would be a positive, whereas if I plugged it in here, I'd have a negative for that. But it doesn't really matter which one you plug it into. All right, let's try one more. All right, here's our next equation. If we were to try to add them together, nothing would equal 0. So we're not able to get rid of the x's and we're not able to get rid of the y's. So what we have to do is we have to multiply one of the equations by something to change it. So we could maybe multiply the first one by negative 1. That way we could end up getting a positive 6x, and 6x minus 6x would be 0. The other option is maybe if we multiply the bottom one by a negative 2, that would make this 3 negative 6, and 6y minus 6y would then be 0. So we could do either one of those. I'm just going to do the first one where we're timesing it by negative 1. Just undo those parentheses. There we go. Okay, so I'm going to rewrite this. So if I distribute this, I have positive 6x. Then it will be a negative 6y. And a negative 6 at the very end. And if I copy my next equation, we have this. Right, so now if I try to add them together, this is worth 0 or nothing, so I don't need those x's anymore. This is negative 3y, and negative 6 plus negative 12 is negative 18. Right, so then I'll divide by negative 3, and we get y is equal to 6. All right, so our final coordinates, the y value is 6. So now I have to go plug that into one of the equations. I'm going to use the I'm going to use the top one. All right, so we have negative 6x. And I'm taking the original equation that I had. Plus 6 times 6, because that's our new y, equals 6. All right, so if I simplify, I have negative 6x plus 36 equals 6. All right, so to get that x by itself, I want to get rid of that integer, so I'm going to subtract it away. So that's negative 30 here and negative 6x here. All right, then to undo that multiplication, the inverse operation would be to divide by negative 6, leaving us with x equals 5. So our point of intersection, or the solution, would be 5, 6.